A jet plane traveling horizontally at 1.0, it's just 1 point times 10 to the power 2 meters per second as speed or velocity drops a rocket from a considerable height. The rocket immediately fires its engines, accelerating at 20 meters per second squared in the x direction while falling under the influence of gravity in the y direction. When the rocket has fallen 1.00 kilometers, find the magnitude and the direction of its velocity. Neglect air drag or aerodynamic lift. All right, so welcome to this video. It's physics foundation and we're looking at motion in 2 dimensions. So this is a very important question, of course, but they're asking us to find the magnitude and direction of the velocity. So step 1 is look at the motion of this object. So the motion of the object is actually concentrated in the y-axis. Okay, it's only in the y-axis. Why? Because of this particular distance which they are showing us. And one thing that you need to know is that as long as it has dropped something, all right, this something which has been dropped, it's going towards, or let me say, it's falling under the influence of gravity. But in terms of distance, it is decreasing. That's why you see the negative there. All right. Having known that in mind, let's now put up the equations and so forth and so forth. Okay. Step 1 is let's first find the velocity in the y direction. Okay. Well, we can find it because it's important. Okay, so for us to find the magnitude, we first need to find the velocity in the y and the velocity in the x. Then what comes to your mind when you hear the word magnitude? All right, it should be something like this. X squared plus y squared. That's where we are going. It's nothing different from there. So let's first find velocity in the y direction. Okay, so velocity in y. So which equation of motion are we going to use here? Well, we're going to use v squared is equal to u squared. Okay, you can call it v initial or here, and of course we are going to say minus y because, well, it's up there, 2g. Then here's where now things change. We are going to say change in the height, this one here, which has been given, all right, for us. All right, now let's just place up like we put everything there. And this is in the y, by the way. So we have velocity squared in the y is, of course, what's the initial velocity in our case? It's 0. It's 0 because this guy is actually starting from rest there. All right, so it's 0. So this guy is 0 there. Then we have negative 2. Have 2. Gravity is, of course, we know it's negative 9.8. And now the change in height is also negative 1 times 10 to the power 3 meters, like that. Okay, let's fire up everything. So that is equal to, let's just punch everything in the calculator. Okay, so I'm getting negative, wait a minute, no, so here it will be positive because this is falling under the influence of gravity, so we keep it that way. So this acceleration will be positive, yeah, which now will give us 1.4 multiplied by 10 to the power 2 meters per second as our velocity. Oh, sorry, wait a minute, we need to square it. I didn't square root, so after I square root both sides, that's when I'm getting this guy here, meaning I need to erase this part there, and I'm getting negative 1.4 times 10 to the power 2 meters per second after I square root. All right, now let's also do the same now in the x direction. But one thing that we know is that in the x, we have first this velocity here, which they gave us. So we have initial which is in the x, is 1.0 times 10 to the power 2 meters per second. That's the initial one that was given. Then what else do we have? We need to find the other velocity, and we can only do it by finding the time. All right, we first need to find the time it takes for this guy here to drop all the way to there. All right, of course we're going to use the y component velocity. We know that the y component velocity, all right, is this plus ayt. We look for the time it will take to fall from there to there. That's what we need, because that time is going to help us find the final velocity now in the x. Okay, so now we plug in everything that we need. So here we've got 1.4 times 10 to, this is 0 there, by the way. This guy is just 0. Acceleration, of course, to be negative. And 9.8. Then we have t there. If we divide, get our t. Okay, 1.4, 10 to negative 9.8. I'm getting 14.3. I'll leave it one decimal place. That's what we are getting as the time that we need. Now this time is important because it's going to help us find the velocity in the x, all right, which will be given by this plus acceleration in the x times t. Now Vx, we don't know it. Vox, it's 1 times 10 to the power 2 plus acceleration in the x was given as here, 20 meters per second squared, and the time of flight is that. So putting everything together, 20 times 14.3, then you say plus 1. I'm getting velocity in the x as 386 meters per second. So this is a velocity in the x. Now that we have the velocity in the y, we have the velocity in the x, let's now find the magnitude, all right, and the direction of that particular velocity. All right, so the magnitude of velocity will be equal to velocity in the, in the y square plus velocity in the x we square, of which we'll be putting negative 1.4 times 10 to the power 2, again squared, plus we have 386 squared. Gather your calculators. So root, open brackets, negative 1.4 log 3, then you square everything, then you say plus, open 386, close square. I'm getting 411 meters per second. That is what I'm getting as the velocity. What about the direction? How do we think direction will be found? So direction will be worked out as follows. We know that we have to, it's just the arctan, all right, of the y component and the x component. So arctan, then you have velocity in the y over velocity in the x. Tan theta, it's just y over x. So it will be tan inverse of velocity in the y was this, okay, and the velocity in the x was 386, like that. All right, so you can punch them together if you want. So okay, it's negative as well. The negative part on the angle, it's just showing you the direction, degrees. Okay, it's just showing you the direction, that's all. Okay, so that's a direction. So of course we can see that when it lands there, okay, when it lands there, it's going to have that and that, then all what we're looking for is that. So it's going to have the y component and the x component, and the y component is what we did here and the x is what we did there. Then what we found was this v here, and they wanted us to find the direction. Of course, the direction can even come here. It's just downwards. It's downwards. That's all. Okay. Yeah. Because you can even see that it's the arrow is going down. So it's down. It's downwards like that. Anyway, you have heard it for yourself. You have known. You have practiced. The best thing is revise.